The other day I was driving by various farm fields and I noticed that in some of these fields, the ones that had that were growing corn and soy, a lot of these fields were actually had quite a few weeds in them, and usually they were specific types of weeds. As herbicide resistance continues to become more severe, this problem may become more common. So in this video, I'm going to go over 5 herbicide-resistant weeds and some of the actual possible benefits that they can actually offer to the landscape, but also some of the growing preferences that some of these weeds may have. Because if we alter certain environmental factors on the landscape, we can alter the types of weeds that actually come up and how aggressively they grow. So of course, weeds can be a very formidable problem or challenge as gardeners, or especially as farmers, right? And especially the larger scale you go, the more prevalent, the more of a problem these weeds are likely going to be, right? To a backyard gardener, pulling out weeds like horseweed is pretty easy, and it's not really that much of a problem, at least per my experience. But when you scale that up to multiple acres or tens of acres or hundreds of acres, that's where the challenge really comes in, and it starts to get very difficult to keep up with some of the weeding pressures. So when I'm talking about not just these 5 weeds, but when I'm talking about any type of weedy type plant, always what I do is I ask myself these questions here, right? So first, I observe the plant on the landscape or in the garden. Can I positively identify what this weed is? Where is it growing? What's the soil like exactly where it's growing? What's the light level? All these different factors. And then I want to identify, as best as I can, a cause, right? So this is where we know what the plant is, and now we really focus on looking into what is the preferential habitat of this plant. Could it be a certain light intensity? Could it be too much shade? Could it be too much water? Could it be, could the soil be too wet? Could it be too dry? Or if we have like a soil test in that area where available, where that weed is growing, are there certain mineral deficiencies or excesses that may point to that may clue us into why this weed is growing on the landscape. And there could be many other environmental factors as well, right? For example, not one of the 5 weeds up here, but dandelion seeds need sunlight in order to germinate, right? So how can we take that and apply that to like a gardening scale, right? Well, maybe we can mulch in between plants to hinder the germination of dandelion seeds, or, so that's kind of where I'm going with that. So once we identify a cause, then we want to identify a purpose. So if you look at it a little too deeply, it's probably more of an ultimate question, but on a basic level, why is this plant here? Not just what on the landscape triggered this plant to grow, but also what is this plant doing to benefit the environment around it, right? Is it able to bring in certain beneficial insects? Is it able to help decompact the soil with like a deep taproot, or prevent erosion by a fibrous root system? Or is it meant to cover the ground, right, and protect the ground? Is it an early succession weed, or is it like a mid or a later succession weed? Or if the soil is poor, is it fixing nitrogen in the soil? And all these different things that we want to consider. So it's like using some of these weeds to identify certain possible imbalances on the landscape, right? Because this information is so valuable, because then we can take it upon ourselves to help facilitate that balance, right? And making sure that we are working with the landscape, by being able to read the landscape, what it needs, and then being able to supplement, right, or do something to reassert that balance. So when I look on the landscape and I see a weed, or it's a certain plant that maybe I don't even know, I haven't identified it, this is the process that I go through in order to try to learn as much as I can about this plant and about the ecology in this area, so that I can become a little bit more knowledgeable as a gardener or a farmer or whatever, rather than blindly spraying plants or not taking into account the context of the landscape and the demands of the landscape or where this landscape is at, right? What successional stage or what a level of health. So now these are the 5 weeds that have become herbicide resistant. Now, these weeds are not resistant to all herbicides necessarily, but some of them are very resistant to various herbicides. Others, like the velvet leaf, are only resistant to, or known to be resistant to, one herbicide like atrazine, and not all velvet leaf is resistant to it, but there are some strains out there that have become resistant. And of course, with all these weeds and other weeds too, as we continue to move forward, and if the spraying and the way it's being done today continues, this problem could very well continue to get worse and worse, right? And then we talk about like the pesticide treadmill effect, and it's just more inputs, more costly for the farms, more risk involved. So how can we kind of work with this as naturally as we possibly can, right? How can we listen to the landscape finally, you know, and learn maybe a different way to treat the landscape, maybe identifying and treating the cause rather than just putting on a band-aid, so to speak, or treating the symptom type thing. First on the list we have horseweed, right? And so I have an N here, and this means that it is actually native to North America. It's a super beneficial plant. The M here actually represents that this plant can actually form mycorrhizal associations in the soil, right? So this is really good for, if you've heard of mycorrhizal fungi, these are fungi that can really help a lot of different plants acquire nutrients from the soil, and they can boost many of the nutritional aspects of our food. And so the horseweed can actually be kind of beneficial in reclaiming the soil, especially because horseweed can be common in degraded soil with low nitrogen, right? So this is like a pioneer plant to help come in and help to rehabilitate the soil in some ways. And then this plant doesn't just help rehabilitate the life below ground, but also helps to rehabilitate the life above ground. I have a P here for pollinator. So this plant is an awesome plant to attract a wide variety of beneficial insects, and so beneficial insects are really good for pest control. So in my garden, I'll weed out some horseweed, but I always make sure to keep a few plants here and there to attract the beneficial insects. Now, of course, this plant does produce hundreds, well, probably thousands of seeds, probably even more than that per plant. And as a gardener, for me, it's not that big of a deal because I can pull it up pretty easily, especially when the plants are younger. Now, as larger scale farms, some methods may involve like shallow tilling early in the season to uproot the horseweed, right? And that might be one possible option. The second plant, of course, is amaranth, right? And there are certain varieties of amaranth, especially like the Palmer amaranth and some others, that have really become resistant to various herbicides. And I have a question mark here because some species of amaranth are native to North America, others are not, right? So it really depends on what species you have. Some of the benefits of the amaranth is that it is a C4 photosynthetic plant. So that means that it's a little bit more efficient at getting energy from the sun than some other plants are, like C3 photosynthetic plants. And it can also be a plant for beneficial insects. In terms of being a pollinator plant, it's a distant relative to buckwheat. I don't know if it can help to make phosphorus more bioavailable in the soil like its cousin buckwheat does, but it's possible. Well, because when we look at the soil preferences here, we see that amaranth may grow in soils that have higher iron levels, lower manganese levels, and also low phosphorus and calcium levels, right? This is really informative because a couple of years ago I did an experiment with growing potatoes, right? And I had a plot where I didn't add any fertilizer. I had a plot where I added the just ground up eggshells as like a calcium supplement, and then I had another plot where I added in calcium acetate, right? And that was from like soaking eggshells in vinegar and then cooking off the vinegar and then collecting that resulting calcium acetate. And then I even just used a small amount of calcium acetate as a fertilizer in the potatoes, and in that specific section where I used the calcium acetate, the potatoes grew a lot worse. among the other groups, there wasn't really much of a difference. But in that calcium acetate spot, all the potatoes were like, the plants were kind of yellowed, they were stunted, they were just smaller, and they just didn't look very lively. So basically that fertilizer experiment with the calcium acetate did the opposite of what I wanted it to. But I learned a lot, right? Because in that specific section where I had the calcium acetate, I also noticed that there were a bunch of lamb's quarters and amaranth growing in that specific spot. It was like night and day to the section next to it, right? So I really altered that soil profile by adding that calcium acetate. And I did some research later. I learned that calcium acetate is pretty strongly antimicrobial, especially in certain quantities. And so I altered the soil structure, and the amaranth really responded, because amaranth comes from a plant family that usually doesn't make huge mycorrhizal associations, right? So it's not dependent on as much biology to grow successfully. And it's also a C4 photosynthetic plant, so it has an easier time getting more energy from the sun. So it makes sense that it would grow in soils with lower phosphorus and calcium. Now, it doesn't necessarily mean that there's a lower amount of phosphorus and calcium in the soil, but it could just mean that the calcium and phosphorus are in the soil, in fact, but they are not available to the plants, right? Because the necessary microbes or communities of microbes are not present to make those specific nutrients available to the plants, right? Next up, we have a plant called cocklebur, right? And this is a plant it's actually a composite, right? It's in the aster family, but the flowers are mostly wind pollinated or self-pollinated too. And this plant is likely to be native. It's not 100% clear on where this plant specifically originated from, but this plant does seem to grow and grow very well in areas that have a high nitrogen content, right? Whether that nitrogen might be naturally occurring, or maybe if it's applied chemically in like a nitrate form too, I wonder. And then typically you'll see this plant growing in areas where the soil might be washed out, right? Maybe it's on the landscape and the geophysical structure is such that there's a lot of like water erosion, and that is where the cocklebur will really grow well, right? In certain fields, if it's like in a bottom corner and all the plants in that area are kind of stunted and small and not growing as well because the soil is getting washed out, and maybe it's getting flooded out in that area because of the grade on the landscape and what. But the cocklebur is very tolerant of those conditions. This cocklebur may also form some mycorrhizal associations, just like the horseweed too, which is also in the aster family. So both of these plants are. But this plant also has a pretty aggressive root structure, which can also help to hold the soil in place in these areas as well. So it's kind of like nature's safeguard to try to preserve the soil as best it can in some of these areas. Fourth on the list, we have velvet leaf, right? This plant is definitely not native. I think it originated from Asia, but it's a really cool plant, and I was always fascinated by it as a young kid. And this plant will typically grow in high nitrogen areas, usually areas with poor drainage, right? So this might be where soil is more anaerobic. This plant can also form some mycorrhizal associations, even in some of these rough and difficult terrains. And then this plant can also be somewhat of a pollinator attractant to certain beneficial insects as well. And then lastly, we have nutsedge, right? Especially the yellow nutsedge, right? Which is actually kind of native to North America. Might be a surprise to some of you, but this plant will grow in areas of poor drainage and usually high water, right? So not necessarily quite swampy conditions, but close to it, usually areas of the landscape that are a little bit lower lying, that may be a bit more of a sink for water. This plant will definitely be more prevalent. It can grow in other areas too, or if there's a field that's over irrigated or heavily irrigated, this plant may also be very prevalent in those situations. But this plant, it also forms mycorrhizal associations, and it can also help to prevent some erosion, right? Especially water-based erosion. in some of these areas, right, where water might be pulling up or commonly flowing through. So sometimes with some of these weeds, if we change some of the environmental conditions, we can make the environment less conducive to the growth of some of these weeds, right? Just one quick example with the velvet leaf, right? We have a high nitrogen situation. So maybe if we tone down the nitrogen fertilization program a little bit, and then we combine that with making the soil a little bit more drainable, right? And this may be a short-term or long-term project depending on the condition of your soil and the resources you have available, right? If we're cover cropping, we're adding in compost depending on your context and what's feasible, and things like that, right? And maybe occasionally tilling it in, or just, you know, mulching it on top to a point at which we are building up that organic matter content in the soil that may help to make the environment less conducive to the velvet leaf, because that'll shift the soil structure to being more aerobic and better drained, and the microbe communities that live in that soil will change as a result, right? And certain microbe communities that once supported the velvet leaf may die off, or those dynamics may change, and different communities will predominate, and the velvet leaf might not get the nutrients that it needs. So thank you so much for checking out this video on the 5 herbicide resistant weeds. Now we know some basic growing conditions that they like. We know a little bit more about their native status, or if they're invasive, but then we also know some possible benefits, right? Typically things in nature aren't all bad, right? They have a good side too, and it just kind of depends on what type of lens that we're looking through. So thank you so much for watching, and I look forward to seeing you in a future video. Take care.